Right now, without touching anything, the device you are watching on this is connected to a network, probably several at once. Your Wi-Fi, maybe some Bluetooth earbuds, and through them, the entire internet. We use network every single hour of every day, and most of us have never actually stopped to ask, what is a network and how does it work? That's exactly what this video is for. This is episode 1 of series where we build your networking knowledge from zero, no confusing jargons, just a big picture explained simply. By the end of next few minutes, you'll be able to explain what network is and four main types and two ways every network is organized. Let's get into it. Here's the plan. First, what a network really is, the simple idea underneath all of it. Then, how networks are already around you. We'll break down into four main types of network: PAN, LAN, MAN, and WAN. Don't worry, those are just four sizes of same thing. Then, the two-way networks are organized: client server and peer-to-peer. And we'll finish with a quick recap so it all sticks. Stick around to the end. I've got a question for you that ties it all together. So, let's start at the very beginning. What is a network? Here's the one line definition. A network is two or more devices connected together so that they can share data and resources. That's it. That's the whole concept. Two key parts there: share data, that's files, messages, photographs, web pages, and share resources like a printer the whole office can use or one internet connection for those whole house. And they can communicate in real time. Calls, chat, games. Now grab two quick words because we'll use them all series. Each device on a network is called a node. The connection between them is called a link. So the simplest possible network is just these two nodes, one link. Connect a laptop and a phone so they can talk. Congratulations, that's a network. And more nodes like this, links, and it gets bigger. And here's the thing. Once you get that idea, you start seeing network everywhere because you are completely surrounded by them. If you have done any of these today, you have already used the network. Your home Wi-Fi, phone, TV, laptop, all online at once. The internet, which is really just the biggest network of them all. Bluetooth earbuds, that's your phone and your earbuds, a network of two. Texting and video calls, tapping your card to pay. That's machine quietly talking to your bank. Gaming and streaming, connecting you to servers and players around the world. So basic idea every single time. Devices connected to share. The only thing that really changes is the size. Before we talk size, let's quickly peek around the hood. Because every network, from your earbuds to entire internet, needs three things. Number one, phones, the devices. Anything that sends or receives phones, laptops, servers, printers, smart TVs are all known as nodes. Number two, a medium. That's the connection itself. How the signal actually travels. It's either wired through cables and fibers or wireless through radio waves like Wi-Fi. Number three, protocol. This is the one people forget. Protocol is just a shared set of rules, a common language, so devices actually understand each other. Think of it like a phone call. You've got two people. Those are your nodes. You've got a phone line. That's your medium. But if one person speaks English and the other only Japanese, nothing gets through. They need a shared language, a common language between them to understand the messages. So, on a network, that shared language is a protocol. Things like Wi-Fi or TCP/IP. Okay, foundation's done. Let's talk about four types of network. And here's the secret that makes this easy. The only real difference between them is reach. How much physical ground of network covers. That's genuinely it. This runs from tiny, just from space around your body, all the way up to entire planet. Four names, one idea, scale. Let's take them one at a time. Smallest first. First, the smallest, a PAN, which is a personal area network. Typical reach, about 10 meters. We are talking the gadgets right around one person, usually wireless, short range, and then basically just pair and go. This is your wireless earbud connecting to your phone, your smartwatch syncing your steps, your phone acting as a hotspot, a wireless mouse. A tip behind it is stuff like Bluetooth and NFC. Here's an easy way to remember. There's a good chance you are wearing a pen right now. Scale up and you get one most people actually run at home. A LAN, a local area network. Reach, about a building. This is devices in a single place, a home, an office, a school, all connected, usually through a router, either over Wi-Fi or an Ethernet cable. Your home Wi-Fi is a LAN. The office building is bigger LAN. A school computer LAN or a LAN party for gaming or LAN. Two things make a LAN a LAN. It's one location and it's owned by person or an organization. And because you control the whole thing, it's fast and it's cheap. This is workhouse of networking. Go bigger than a building, but not as far as whole country. That's your man. A metropolitan area network. The clues in the name metropolitan, it covers a city. A man links lot of lands together across the city. Think a university with campuses over all the town, all connected, or a cable company wiring up an entire city. Usually it's an internet provider or a city itself running fiber across the metro area. This is honestly type people talk about the least, but it's the bridge. It's the between your local network and the giant global ones we are about to hit. And there are the giants. A WAN, a wide area network. Reach countries, continents, the entire globe. The WAN connects network across the huge distances using fibers, satellites, literal cables running across the ocean floor. And here's the big one. The fact I really want you to take away from this whole section, the internet is the world's largest WAN, which is WAN. It's a network of networks. All those LANs and MANs linked together on a massive scale. When a bank connects every branch across the country, it's a WAN. So that's network by size. But there's a second way of think about them, and it's just as important. Forget about big the network is for a second and ask different question. Who's actually in charge? Inside any network, there are two classic ways to organize the conversation. One is central boss, the other is team of equals. Let's look both of them. First one, client server. This is the model behind most of the internet. The idea is simple. Client asks and the central server answers. A client is just a device making a request like your web browser. The server is a powerful central machine that holds the data and responses. Watch how it works. Step 1. Your device, the client, sends a request. Hey, show me this web page. Step 2. The server does the work, finds the page, checks you're allowed to see it. Then the step 3, the server sends a response back and the page appears on your screen. All of that in a fraction of a second. You use this constantly. Every website, your email, Netflix, online banking, and notice in the diagram, every client talks to the server in the middle, never directly to each other. The upside, it's centralized. So it's easy to manage, easier to secure, and everything stays consistent. The downside, the server is the single point of failure. If it goes down, everybody's stuck. And running it costs real money. Now, flip it completely. Peer to peer or P2P. Yes, there is no central boss. Instead, every device is both a client and a server at the same time. We call them peers, and they share directly with each other. Look at the diagram. There is no center. Everyone is connected to everyone. A few things fall out of that. Every peer is equal. No single machine is in charge. They connect directly, each one each one both asking for and giving data. And because there is no center, the network itself heals by itself. Use one peer and the rest just carry on. And use it. BitTorrent, airdrop, and the whole idea behind blockchain and Bitcoin. The upside? No expensive central servers. It scales naturally and more people join. And it's incredibly resilient. The downside, it's much harder to secure and manage. The data isn't always there. If the peer holding it goes offline, it's gone. So, head to head, client server is centralized, peer to peer is distributed. Client server costs more because someone has to run that server. P2P spreads the cost across everyone. Client server is limited by the server. P2P actually gets stronger with every peer that joins. Client server has the single point of failure. P2P is wonderfully resilient, but client server is easier to lock down and secure, while P2P is harder to control. And the key takeaway is neither one is better. There are trade-offs. Most of the apps use client-server architecture because it's easier to control and secure. P2P shines where you specifically don't want a centralized authority. All right, let's lock it all in. Four things to walk away with. One, a network is just two or more devices connected to share data and resources built from nodes, which is also called hosts, a medium to communicate and carry the data or resources, and protocol, which is the rules to govern the communication. Two, networks are grouped by reach. PAN is you, LAN is a building, MAN is a city, WAN is the world, and the internet is biggest WAN of all. 3. Client server means one central server answering many clients. That's most of the web. And 4. Peer-to-peer means equal peers sharing directly with no central server. That's it. That is a genuinely solid foundation. And that's a wrap on episode 1. Seriously, if you followed all of that, you now understand the fundamentals of how every network on the earth is built. If this helped it finally click, do me a quick favor. Drop a like, it genuinely helps the channel, and subscribe because this is a series and every episode builds on this one. Hit the bell icon so you don't miss the episode 2. But before you go, I've got a quick question for you and really want to know which type of network does your home run on? Drop your answers in the comments. Thanks for watching. I'll see you in episode 2.